Welcome back to our discussion of advanced linear algebra. In this video, we will study the singular value decomposition. I am feeling very happy that this is going to be the last lecture on advanced linear algebra from the theory point of view. Okay, we have already discussed many form of a linear transformation. जब हमने linear transformation को discuss किया था, then we have two vector spaces that V and W. When we say that a linear transformation is from a vector space V to itself, that is the domain vector space and the codomain vector space both are same, then that linear transformation now is known to be linear operator. फिर इसी लीनियर ऑपरेटर को विद सपोजिशन वी कॉल्ड इट नॉर्मल, देन वी आइडेंटिफाई एडजॉइंट, सेल्फ एडजॉइंट, then orthogonal projections etc. Okay, but in the discussion of adjoint we required two concepts. First is of the orthogonal, and then another is the inner product. Okay, now what do you mean by orthogonal? कि हम orthogonal process के through we can always obtain an orthonormal basis. Okay, so if I say in a more precise way, then I can say कि जब हमने adjoint को define किया था, then we required in the concept of inner product space and the orthonormal basis. Okay, so in that sense when we define the adjoint for linear operator, तो इसमें हमने डिफाइन किया था कि इफ t is v to b, okay, be a linear operator on inner product space v. Okay, then the t star defined from v to b such that inner product t of x comma y is equal to x comma t star y for all x and y in v is said to be adjoint of t. Okay, so here we require the concept of this inner product. Okay, now if we have a linear transformations only, okay, वो operator नहीं हो तो इस केस में we required orthonormal basis to define this adjoint of a linear operator. Okay, so I'm just writing some observation, then we will start the discussion of singular value decomposition. Okay, now we are going to identify adjoint for a linear transformation. Okay, so let u, v and w be two finite dimensional inner product spaces, and let beta and gamma be orthonormal basis for u, v and w respectively. Okay, then in that case we can always consider the matrix representation of a linear operator. So suppose we have a linear operator, let t be a linear operator from v to w. Okay, linear transformation. Now for this transformation we are going to define the adjoint. Okay, be a linear transformation. Okay, then the function, or more precisely you can say the linear transformation. linear transformation T star defined from W to V is defined from V W to V such that the matrix representation of T star in gamma and beta is equal to the adjoint of matrix in beta and gamma adjoint. Okay, so the adjoint of T is the adjoint of matrix of T. Okay, so this is how you can relate this T star and T. Okay, so that this is said to be adjoint of T. So this is how we can define the adjoint for a linear transformation. Okay, now the moment we have the adjoint of this linear transformation, then we have proved that rank of T star T is same as rank of the linear operator T. Okay, so we have this kind of results. Now based on this discussion, we are going to define the singular value theorem for linear transformations. So we are defining the definition. So matrices और ट्रांसफॉर्मेशन दोनों के लिए हम डिफाइन करेंगे. ठीक है, वैसे इस पर दी सिलेबस हमें केवल डेफिनेशन से डिस्कस करनी है, बट स्टिल आई विल राइट सम इम्पोर्टेंट स्टेटमेंट हियर. वैल्यू singular value for linear transformation. Okay, so let V and W be finite dimensional inner product spaces and let T is defined from V to W be a linear transformation. Okay, of rank R. ठीक है, then there exist orthonormal bases, that is V1 V2 and so on, Vn, and this is for V and the bases U1 U2 and so on Um for W. Okay, and positive scalars sigma 1 greater than equals to sigma 2 greater than equals to and so on greater than equals to sigma r. So जितना इस लीनियर ट्रांसफॉर्मेशन का रैंक है उतने ही हमें ये सिग्मास मिलेंगे. ओके, such that the T image of every Vi is equal to the sigma I ui if this I is in between 1 and r, and this is going to be 0 if this I is greater than r. ठीक है, सो ऐसा रिलेशन हमेशा हमें मिलेगा. ओके, एंड कन्वर्सली जब आपको सिंगुलर वैल्यूज की डेफिनेशन पूछी जाए देन यू विल राइट दिस स्टेटमेंट. ओके, कन्वर्सली suppose that there exist positive scalars sigma 1 greater than equals to sigma 2 greater than equals to and so on greater than equals to sigma r. Okay, such that this t of vi is equal to sigma I ui if I is in between 1 and r and 0 if this I is strictly greater than r. Okay, then in that situation, then for I running from 1 to n, this vi is an eigen vector of t star t with corresponding eigenvalues सिग्मा आई स्क्वायर. सो यू कैन सी जब कोई भी हमारे पास ऐसा रिलेशन है तो सिग्मा आई स्क्वायर विल बी आइगन वैल्यूज. या फिर आप ये कह सकते हैं कि अगर आप टी स्टार टी की आइगन वैल्यूज को आइडेंटिफाई करेंगे और उनका स्क्वायर रूट लेंगे देन यू विल हैव योर सिग्मास. और इन्हीं को ही हमने आइडेंटिफाई करना है थ्रू आउट द लेक्चर. सिग्मा आई स्क्वायर if eigenvalues if this I is running between 1 to r and 0 if this I is greater than r. ठीक है, these scalars are unique and these unique and these unique positive scalars are called the singular values of t. Okay, now we have an important concept that if the rank of t that is equals to r is less than both dimension of v that is equals to n and dimension of w that is equals to m, then the term singular value is extended to include sigma r plus 1 equals to sigma r plus 2 equals to and so on equals to sigma k equals to 0, where this k is equal to the minimum of m and n. ठीक है, तो जो भी मिनिमम हो वहां तक की जो सिग्मास है दैट कैन बी कंसिडर्ड एज 0 इन केस वेयर दिस आर इज लेस देन दी both the dimensions. Okay, so this is about the definition of singular values of a linear transformation. Now let us identify कि ये singular values को हम कैसे find करते हैं. ठीक है, so we are discussing that how to obtain singular values for linear transformation. ठीक है, so for to understand this we will consider an example and this is example number 1. ठीक है, so let P to R that is the space of polynomials up to degree 2 and P1 R be the polynomial spaces spaces with inner products defined by the inner product of fx comma g of x is equal to the integration from -1 to +1, ये हमने डिस्कस किया ही था, product of ft zt dt. Okay, now consider a linear transformation that let t from p to r to p1r, okay, be the linear transformation defined by t of fx is equal to f prime x, that is the first derivative of the polynomial. Okay, then find the singular values of t. ठीक है, solution. So given that t from p to r to p1r defined as t of fx is equal to the first derivative of fx. ठीक है, now to find the singular values we find orthonormal basis beta, that is equals to v1 v2 v3 for p2r and another orthonormal basis gamma, that is equals to u1 u2. ये एक प्रोसेस है जो आपने फॉलो करना है when you are asked to identify the singular values for some linear transformation. Okay, for p1 r such that t of vi is equals to sigma I ui for I is equals to 1 and 2, and t of v3 is equal to 0, where these sigma 1 is greater than equals to sigma 2 strictly greater than 0 are the non-zero singular values of t. ठीक है, तो हमें ये सिग्मास को आइडेंटिफाई करना है, ठीक है, जिससे कि t of vi को हम इस पर भेज सके. Now you can see why we are writing that this is equal to I is equal to 1 and 2. Why this I is varying from 1 to 2? You can see in the definition that I कहाँ से कहाँ रन करता है. This I is running from 1 to R, और R किसको रिप्रेजेंट करता है, रैंक को. सो यहाँ पर हम पहले ये शो करेंगे दैट रैंक ऑफ T इज 2, और रैंक को हम कैसे डिसाइड करेंगे, इस T का मैट्रिक्स रिप्रेजेंटेशन आइडेंटिफाई करके. ठीक है, बट बिफोर दैट वी मस्ट हैव सम ऑर्थोनॉर्मल बेसिस. जब भी हम सिंगुलर वैल्यूज को डिस्कस करेंगे वी मस्ट हैव ऑर्थोनॉर्मल बेसिस. ठीक है, अब क्या हमारे पास P1R और P2R के कोई वेल नोन ऑर्थोनॉर्मल बेसिस है? हमने ऑलरेडी प्रीवियस लेक्चर्स में इनको डिस्कस किया था. यू कैन collect these ideas from those lectures. So first of all we will identify the rank of T. ठीक है, so first rank ऑफ टी। और इसको आइडेंटिफाई करने के लिए टू फाइंड दिस वी फाइंड इट्स मैट्रिक्स रिप्रेजेंटेशन। ओके, तो सबसे पहले हम मैट्रिक्स रिप्रेजेंटेशन को आइडेंटिफाई करते हैं और इसके लिए वी नीड टू कंसीडर सम ऑर्थोनॉर्मल बेसिस। ओके, सो लेट अल्फा that is equals to 1 by square root of 2 comma square root of 3 by 2 x comma square root of 5 by 8 3 x square minus 1 and alpha prime that is equals to 1 by square root of 2 comma square root of 3 by 2 x। ओके, ये दोनों ऑर्थोनॉर्मल बेसिस है फॉर आर ऑर्थोनॉर्मल बेसिस फॉर P2R and P1R respectively। ओके, इन दोनों ऑर्थोनॉर्मल बेसिस को हमने लेक्चर नंबर 17 में डिस्कस किया है। यू कैन फाइंड लेक्चर नंबर 17 in form of example number 5। okay, and the time duration is 56 minutes 20 seconds। okay, so in this lecture you can find at this time this whole discussion। okay, we have already done this in this 17th lecture। ठीक है, so we have these two orthonormal bases for the P2R and P1R respectively। then you can have the matrix representation of this T in form of alpha and alpha prime। okay, then the matrix representation of T is A, and that is equals to the T from alpha to alpha prime। and this is easy to identify। अगर आप इसका डिफ्रेंशिएशन करेंगे तो दिस विल बी ज़ीरो, और ज़ीरो को हम लीनियर कॉम्बिनेशन में लिखेंगे दैट इज इक्वल्स टू ज़ीरो एंड ज़ीरो, राइट। जब आप इसका मैट्रिक्स रिप्रेजेंट सॉरी इसका जब डिफ्रेंशिएशन करेंगे सो इट विल बी स्क्वायर रूट ऑफ 3/2 एंड वी हैव ऑलरेडी स्क्वायर रूट ऑफ 2, सो वी जस्ट नीड टू मल्टीप्लाई बाई स्क्वायर रूट ऑफ 3 only। so this will be the second column, and again you can, if you differentiate, then you will have the 0 square root of 15। so this is how you can identify the matrix representation of T। now you can see, now since the rank of A is equal to 2, therefore the rank of T is equals to R, that is equals to 2। जो A का rank होगा that will be the rank of the linear transformation as well। okay, so यहाँ पर हमने मैट्रिक्स की रैंक को आइडेंटिफाई कर लिया है। ठीक है, सो वी हैड डन दिस रैंक ऑफ टी। ठीक है, नाउ वी आर कमिंग टू दी सेकेंड थिंग दैट इज द प्रोडक्ट A star A and its eigenvalue and eigenvectors। ठीक है, सो फर्स्ट ऑफ ऑल विल आइडेंटिफाई कि A स्टार A क्या बनेगा। सो यू कैन सी A स्टार A इज गिवन बाय, क्योंकि सारी एंट्रीज रियल है, सो यू कैन सी वी कैन राइट दिस एज 0 0 square root of 3 0 and then 0 square root of 5 15। okay, then we need to multiply this by the 0 0 square root of 3 0 0 square root of 50। okay, and that is equal to the 3 cross 3 matrix. You can see 0 0 0, then we have 0 3 0 0 0 and 15. Okay, so this is our A star A. Now we need to calculate the eigenvalues. So this is our A star A. Now we are identifying the eigenvalues of A star A so that we can identify the eigenvectors. Okay, so जब भी हम आइगन वैल्यूज को लिखेंगे वी विल इंट्रोड्यूस द कैरेक्टरिस्टिक पॉलिनोमियल. ओके, सो लेट एफ टी बी द characteristic polynomial of a star A. Then the eigenvalues of A star A is given by f of t is equal to 0. Now what is f of t? That is the determinant of, which implies that determinant of ft will be the A star A minus ti. We need to identify the determinant of this matrix, and that is equals to 0. Now if you could see, then this A star A is nothing but the 0, and I am just subtracting t from the diagonal entry. So we will have minus t 0 0, then we have 0 3 minus t 0 0 0 and 15 minus t, and we need to identify कि इसका determinant 0 होगा. ठीक है, then this implies, you can see, if we write minus t, then 3 minus t and 15 minus t, then this implies that t is equal to 0 3 and 15. So we have these three eigenvalues. Okay, hence you can say, thus eigenvalues are lambda 1 is equals to 15, lambda 2 is equal to 3, and lambda 3